Times when you would like to build your own application and deploy and manage your own data, and all you really need are the computing resources to be able to run that application. In that model, you want to use infrastructure as a service, or IaaS. Sometimes you'll see this referred to as hardware as a service, or HAAS, because you're effectively using hardware in the cloud and then using your own software on top of that. This means that you would be responsible for installing your software and managing all of the data associated with that software. If the software needs to be upgraded, you would be the one to upgrade it on your infrastructure as a service model. The application that you're using and the data that you're putting into that application is still in the cloud, but you have much more control over the access and security of that data when you're using infrastructure as a service. A good example of infrastructure as a service is with web service providers, where you can buy time on a particular web server and they make that server available to everyone on the internet. A middle ground between software as a service and infrastructure as a service is platform as a service, or PaaS. This is still in the cloud, but you're the one who manages all of the development efforts to customize the application to your specifications. The cloud provider gives you all of the tools necessary to build this particular app. You can think of this as a series of building blocks provided by the platform as a service infrastructure, and then you build out those blocks to create your own application. The underlying engine that runs the application is the responsibility of the platform as a service provider, and your responsibility is to build and maintain the apps that are running in platform as a service. A good example of a platform as a service infrastructure would be something like Salesforce.com, where they give you all of the tools necessary to create a customized application running on the Salesforce.com platform. Here's an example of a cloud responsibility matrix that you might find with any cloud service provider. In this chart, I've separated out software as a service, platform as a service, infrastructure as a service, and then an on-prem device that you would manage yourself. Obviously, with on-prem, everything from the data to the applications to the physical data center are all the responsibility of the customer. But with infrastructure as a service, you have the physical data center, the physical network, and the physical hosts, all provided by the cloud provider, and then you handle all of the other pieces of that particular application. With platform as a service, you can see that network controls, applications, and the identity and directory infrastructure may be shared between the customer and the cloud provider. But you'd still be responsible for the accounts, devices, and the information and data. With software as a service, much more of these are provided by the provider themselves. For example, everything associated with the applications is clearly in the responsibility of the provider. Everything above that would still be the responsibility of the customer. So depending on the type of infrastructure you want and the type of responsibility that you're willing to take on, you'll need to pick the right cloud model for your application deployment. In this course, there will be a lot of conversations about TCP/IP, moving packets across the network, and very often we lose track of exactly what that means. So I thought it would be good if we started with an overview of Internet Protocol and how it operates. The goal, of course, is to get data from one side of the network to another. And there are a number of different processes involved in being able to transfer large amounts of data from one computer to another. In the analogy that we use today, we're going to describe this transfer of data from one device to another as using a moving truck to get data from one house to another. We can also think of the roads that we're using as the network that we've created. This might be a wired Ethernet network, a wireless network, a wide area network technology, or many different types of network connections. But in this explanation, those network connections are referred to as the road that our moving truck will drive on. In this example, this truck is the Internet Protocol. It's the one that is doing the heavy lifting and moving that data across the network. Just as we might pack up items or objects in a room into a box and put that box onto the moving truck, we do effectively the same thing with our application data. We package that information into a virtual moving box, and we put that moving box onto the truck, which in this case would be IP. So now we have a highway, which would be our network. We have a moving truck, which would be the internet protocol. We have boxes within that moving truck. We commonly refer to those boxes as the TCP or UDP protocol. And then inside of those boxes is application data that we need to transfer from one device to another. This process of encapsulating data within other protocols, which are then encapsulated within even larger protocols, is a fundamental process when we describe the transfer of data across the network. If we were to visualize the Ethernet frame that we use on our networks, it would look a lot like the one that we have on our screen now. We have a client that is communicating to a server, and information is being sent between those two devices. You'll notice there is an Ethernet payload in the middle of this frame. At the beginning of the frame is an Ethernet header, and at the end of the frame is an Ethernet trailer. If we were to provide a little more detail about what's inside of that Ethernet payload, you would see there would be some IP information, and within the IP header, the rest of the packet has the IP payload. Deconstructing this further, you can see that the IP payload consists of a TCP or UDP header, and inside of that part of the packet is the TCP or UDP payload. So if we were to look at a protocol decode of a single frame on our Ethernet network, we would see an Ethernet header. Inside that Ethernet header would be an IP header. Inside the IP header might be a TCP header, which would hold HTTP or website data. And then finally, at the end of the frame, we would have the Ethernet trailer. You'll notice that inside of that IP header, we had either TCP data or UDP data. So it might be useful to break out those two protocols and describe what the differences might be. Both of these protocols are very similar in their function. They're obviously moving data from one device to another, but the internals of how those protocols work are a bit different between the two, and an application will use the one that makes sense for its particular function. If you recall our video on the OSI model, you'll remember that TCP and UDP operate at OSI layer 4, or the transport layer. It's in this layer that we're able to send many different applications across the network simultaneously between exactly the same devices. We refer to this as multiplexing, and it describes the efficient process of transferring multiple applications simultaneously between multiple devices. Let's first look at TCP, or the Transmission Control Protocol. We refer to TCP as a connection-oriented protocol. That's because there is a formal process to set up the communication between two devices, and when that communication is done, there's a formal process to tear down that particular session. One feature that makes TCP different than UDP is the ability for a station to acknowledge that it has received data. We refer to this as a reliable delivery method. That's because sending data to another device will always result in an acknowledgement that that device has